In this video, we're going to solve 2003 AP Calculus Form A FRQ Question 2. So it says a particle moves along the x-axis so that its velocity at time t is given by v of t equals negative quantity t plus 1 sine quantity t squared divided by 2. At time t equals 0, the particle is at the position t equals 1. Okay, so that's the initial. Find the acceleration of the particle at t equals 2. Is the speed of the particle increasing at time t equals 2? Why or why not? Okay, so we're going to have to find the sign of velocity and the sign of acceleration. So let's find that. So if you do v of 2, v of 2 is going to equal negative 1 sine of 2 squared is 4, 4 divided by 2 is 2. So between pi over 2, let's think about the graph of sine. Sine does one of these. It does like a hump up into 3.14. So this is definitely going to be negative because it's reflected. So it's less than 0. So if acceleration has the same sign, it's going to be increasing the speed. And if it has a different sign, it's going to be decreasing. So now we have to find the acceleration. A of 2 is going to equal v prime of 2, which is going to equal, let's use our calculator and solve this. Okay, when you use your calculator, you should get approximately 1.588. Since the signs don't match up, the speed is decreasing because the sign of v of 2 and a of 2 are different. Okay, part B. It says find all times t in the open interval from 0 to t. 0 is less than t, which is less than 3 when the particle changes direction. Justify your answer. Okay, so all you have to do here is graph this. So you're going to get your TI-89 or whatever calculator you use, and you're going to type in this function. You're going to change the window and just use x instead of t. So I'm inputting it in right now. X squared divided by 2. It's saying I'm missing a parentheses. Nope, I'm not. Okay, so now window 0 to 3. Okay. So graphing it, it looks like there's only one spot where it changes direction. And it looks like it's a min. It definitely is a min. So it changes direction at 2.5. So part B, the particle changes direction at t equals approximately 2.057 because v was less than 0, then v was greater than 0 at 2.507. Okay, so now part C. Part D says during time interval from 0 is less than t, which is less than or equal to 3, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. So it's going to be either at an endpoint or at a critical point. So t of 0 is going to be 1 plus the integral from 0 to 0 v of t dt. So that's going to be simply 1 plus 0, which is 1. T of 3 is what we found before, but we don't want the absolute value because that's the total distance. So it's 1 plus the integral from 0 to 3 v of t dt. And you're going to get about negative 2.20, because you have to round up. So negative 2.20. Okay, that leads us to our last point. It's the part that we found in part B, which was the 2.507. Or you could say the root of 2 pi, which I believe that's what the AB test does, or a College Board. So 0 to 2.507 v of t dt. When you do this, you're going to get negative 3.26. You have to add the 1, so it's negative 2.26. Negative 2.265. So now compare all these numbers. Which one is the biggest? Is it going to be one where I move nowhere? Is it going to be the 2.507 where, I'm sorry, the negative 1.19? That should be negative 1.19. I didn't add the 1 here either. Or is it going to be this? It's definitely this. So the greatest distance moved, the greatest distance happens to be at the min, is 2.265, which is the min, because it's negative, and occurs at the root of 2 pi. I hope this video helped.